Here's problem 1032. When the sum of the external forces and the sum of the external torques on a body are both zero, we can conclude that. So here's the key word: sum of the external forces and the sum of the torques are both zero. We conclude that, well, if the sum of the external forces is equal to zero, and usually that's ma, that means that the acceleration is zero. So our linear acceleration is zero. And if the sum of the torques is zero, which is the moment of inertia times angular acceleration, and that would mean that the angular acceleration is zero, so our angular acceleration is zero. So these two things would be zero in this case. That means we have no change in velocity. Our change in velocity is zero, because that's the change in velocity over time for the acceleration, and no change in angular acceleration, or angular velocity. So let's look at our possibilities. The body is moving at constant velocity. That could happen, but is not rotating. Well, it could have constant velocity to have no acceleration, but it could be rotating. It could be rotating at constant angular velocity, and that way it would have a angular acceleration of zero. So to say that it's not rotating is not true. So that's not true. The body is rotating at constant angular velocity. That's possible, but has no linear velocity. Well, that's not true. It could have a constant linear velocity, giving it an angular linear acceleration of zero. So that's not true. The body has neither linear nor angular velocity. That's not true. It could be constant. The body may have constant linear or angular velocity, but not both simultaneously. Well, that's not true. So we're left with the body may have constant linear or constant angular velocity, or both simultaneously. That is true, because we have a linear acceleration of zero and angular acceleration of zero. So we may have a constant linear velocity and a constant angular velocity, or both. So that is true. That is our answer, E.